Welcome to this explainer. I am super thrilled you're here because today I'm going to be acting as your personal career mentor. We're going to map out your exact journey going from a first-year engineering student to a highly paid, highly sought-after tech innovator by the time you graduate in 2026. If you've ever wondered how to really position yourself at the absolute cutting edge of the hardware and software revolution, well, this is your blueprint to launch. But before we dive into all the heavy technical details and, of course, the salary figures, I want to anchor our session with this awesome quote from Casper Coleman, an R&D software engineer over at HP. It perfectly captures where a career in hardware truly begins. It starts with simple human curiosity. You know, that urge to just grab a screwdriver, open up a gadget, and uncover the secret language between the physical machine and a digital world. That curiosity, that is absolutely your greatest asset. So, if we take that childhood tinkering and fast forward to today, we really have to ask ourselves, where is the engineering field actually heading in 2026? Think about it. The gadgets we're opening up today aren't just calculators or basic computers anymore. They're smart, they're constantly connected, and they are literally learning. We are witnessing massive global shifts in technology right now. And to succeed, you need to know exactly where the demand is pointing. Let's kick things off with Section 1, the AI semiconductor shift. This is where it gets wild. The fusion of artificial intelligence and advanced hardware is completely rewriting the rules of the tech industry, creating opportunities that honestly didn't even exist 5 years ago. Now, traditional engineering often forced you to choose an isolated lane, right? You had to ask, am I designing the physical hardware or am I writing the software? Today, the most lucrative and emerging roles are strictly interdisciplinary. We're talking about designing AI accelerators, edge processors, and intelligent hardware that requires a deep, deep understanding of both worlds. You really can't just know one side of the coin anymore. Which brings us to Section 2, ECE versus CSE. Let's break it down. Because of this massive shift, students face a really tough dilemma. Let's look at computer science engineering compared to electronics and computer engineering. While CSE focuses heavily on the software side, your algorithms and data structures, ECE gives you the ultimate domain flexibility. It actually integrates electrical engineering with computer science. It marries the physical circuits like VLSI and IoT devices right in with the digital code. So you aren't just writing the software, you are building the physical brains that actually run the software. Moving right along to Section 3, your engineering study guide. So, how do you actually get there? As you move through your second, third, and fourth years, your core hardware coursework becomes absolutely vital. To build the future of AI infrastructure, you first have to master the physics. You'll be taking deep dives into electron devices, semiconductors, and transistors. You'll be learning all about carrier concentrations, p-n junction diodes, and MOSFETs. Seriously, you have to understand the fundamental physics of how a 1 and a 0 are physically created in a circuit before you can optimize them for complex machine learning models. But listen, ECE isn't just soldering and circuits. The crucial point here is that you will also be heavily tested on your programming foundation. You're going to dive deep into C programming, mastering data structures and algorithms. You need to know how to manipulate pointers, write efficient functions, and handle file operations. Because honestly, the hardware is totally useless without the software to drive it. As your mentor today, I want to give you 3 non-negotiable study tips sourced directly from successful recent engineering graduates. Number 1, practice coding daily on platforms like LeetCode or HackerRank. It builds the exact logical reasoning you need for technical interviews. Number 2, master your circuit analysis and network theorems. Practice those derivations until they are totally second nature. And number 3, this is a big one, maintain your physical and mental health. Get sleep, exercise, and manage your stress. A burned-out brain cannot build the future. All right, Section 4, emerging roles and workflows. Once you finally conquer that syllabus, what do these jobs actually look like day to day? Well, you're going to see a massive spike in highly specialized titles. Take the Edge AI engineer, for example. This is someone who develops intelligent hardware devices that process machine learning algorithms locally, right where the data is collected, rather than sending it all the way to a cloud. Or you might become an AI chip architect, someone who specifically optimizes processors to handle incredibly heavy network workloads efficiently. And the daily workflow of a chip designer, it is being completely revolutionized. You aren't just designing chips for AI, you're actually using AI to design the chips. Machine learning models are now used to optimize architectures and layouts way faster than a human ever could.
AI is analyzing production data to instantly detect manufacturing defects, and automated testing algorithms are predicting exactly when and how a component might fail. It is a completely data-driven workflow from top to bottom.
Now for the part everyone always asks about. Section 5. Salaries and placements. Let's talk about the financial rewards. We can walk through this placement data to give you some really realistic expectations based on the tier of your educational institution in India. If you're graduating from a top government institute like an IIT, you are looking at average packages around 21 to 22 lakhs per annum, with the highest packages hitting an incredible 55 to 60. Top NITs and BITS Poloni are seeing averages of 12.5 to 18, and private Tier 1 colleges are securing highly respectable averages of 5 to 8.5 LPA, scaling all the way up to 25. The immense demand is driving these numbers up across the board, particularly for semiconductor and VLSI roles.
But watch what happens when we look internationally. For senior hardware and AI roles in major tech hubs like Silicon Valley, Austin, or Seattle, starting compensations absolutely skyrocket, easily crossing the $150,000 mark annually. If you hold a highly specialized skill set in something like AI chip design or machine learning integration, your earning potential is truly, truly exceptional.
Which perfectly tees up Section 6, Global Job Opportunities. You see, your newly acquired ECE degree is not just a regional certificate. It's practically a passport to the international job market. Looking at overseas demand, Canadian telecommunications and IT sectors are aggressively hunting for professionals skilled in Python, Java, and C. Australia is seeing a massive boom in the need for full-stack and mobile developers. And over in Europe, German tech hubs like Nuremberg and Munich are actively recruiting IT and hardware specialists. Your skills are globally transferable and universally in demand. So we've mapped the coursework, we've looked at the revolutionary new workflows, and we've seen the incredible financial and global opportunities. The entire industry is fundamentally shifting from just writing software to building the intelligent, physical brains that power it all. The roadmap is right in front of you. The only question left is, are you ready to build the future? Thank you so much for joining me on this explainer. Now get out there and start tinkering.